Okay, so this is what I learned yesterday about stereospecific and stereoisomers. So I'm going to draw the hydrogens on here in pink. And then I'll draw what is alpha and what is beta. So here we only actually have one beta hydrogen because the other beta carbon doesn't have any hydrogens on it. So because of that, it can only make one other stereoisomer. So it either has to be cis or trans. It cannot be both. And we have to do a Newman projection in order to understand this, but I always just draw it out again. So I can know exactly what I'm looking at and like draw the arrow from where I'm looking at it. So I'm just gonna do that really quick. And so we need the beta hydrogen and the chlorine to be 180 degrees from each other. So they need to be in line. In this example, they already are, but sometimes they're not, and that's how you figure out if it's cis or trans. So here, I'm just gonna draw the Newman projection. I'm gonna use R as the phenyl ring. I'm just gonna use R as an example. And then I'm going to fill in everything else. And so if we're looking at it from that direction, hydrogen will be away from us, chlorine will be towards us, or out to that side. Highlight it. So we don't care about anything except for the beta hydrogen and the chlorine. So we're going to place our chlorine there and then fill in everything else. So we have our ethyl group, then we have our other hydrogen, then we have our methyl group. But we only care about the beta hydrogen. So because these are already 180 degrees away from each other, we don't need to change anything. But if they were not 180 degrees away from each other, then we would need to change something. And I don't know how to spell, but it's okay. And so when we look over at our options, major product, well, I'm actually going to draw the major product. And also all of the stereo isomers in space go away. So then everything, all of the hydrogens won't be mentioned and the methyl group will just be a straight line. And so we know it has to be trans because as I circled, so R, we're talking about on what side of the double bond they are. So obviously we have R and CH3 have to be on the same side of the double bond because they're together and they're like on the same side of where the chlorine and hydrogen made the double bond. So if that kind of makes sense. And then the ethyl and the hydrogen that's not shown have to be on the same side. So that's kind of what I'm drawing there. And this is obviously going to be the major product that's right next to it where it says major product. But because there's only one beta hydrogen, there's only going to be one major product and there will be no minor product formed.